Hello students, today I am going to take up the main reactions of alcohol, phenol and ether. There are only three main reactions in the chapter alcohol, phenol, ether. Number one, Call-based reaction, Remer-Timing reaction and Williamson synthesis. Call-based reaction, in this phenol, when OH attached to benzene, it is known as phenol. When phenol treated with NaOH, sodium hydroxide, it will form O negative Na positive. This is known as sodium phenoxide. And at 400 Kelvin and 427 atmosphere, when we treat it with carbon dioxide, it will give CO negative Na positive, and with the attack of H plus ion, it will give you OHCOOH. This is known as 2-hydroxy benzoic acid, or it is known as salicylic acid. So this is very important conversion and the name reaction. When you have the question, convert phenol to 2-hydroxybenzoic acid, or the simple name reaction, the Call-based reaction. Or you have the question, convert phenol to salicylic acid. We have OH at second position and COOH at the first position. It is also known as ortho-hydroxybenzoic acid. In the similar manner, we have the Riemann-Timing reaction. Just see. In Riemann-Timing reaction, this phenol treated with CHCl3 in the presence of NaOH, this is known as chloroform, and we get one intermediate between them, CHCl2. Again, this is the intermediate. Again, on passing with NaOH, it will give CHO, and hydrolysis, it will give us aldehyde at the first position. In the previous Call-based reaction, we have acid group. Here we have the aldehyde group. It is known as 2-hydroxy benzaldehyde, or we can say salicylaldehyde, or we can say this is ortho-hydroxy benzaldehyde. Got it? Okay. Now the third one is Williamson synthesis reaction. This is actually from ether. From the part ether. So in this Williamson synthesis, we are preparing ether from alkyl halide and sodium alkoxide ion. So when we combine these two, we'll get the ether. How? See, we have CH3, CH2, Cl, and I'm going to take CH3, CH2, O, Na positive. Earlier it is CH3, CH2, OH. Earlier it was ethanol. When treated with sodium, it will give you CH3, CH2, O, Na positive. To make this compound reactive, that is why I will attack ethanol with sodium. So it will form sodium alkoxide. It is known as sodium. Now it is known as ethoxide. Got it? So when we have these combination, we'll be getting Na and Cl will remove off, and we'll be getting CH3, CH2, O, CH2, CH3. And NaCl is a side product. And it is known as ethoxyethene. Is it clear to everyone? So whenever we have the two products, one is alkyl halide, another one is sodium alkoxide ion. When they treated together, it remove NaCl and form ether like alkoxy. This is known as ethoxyethane. But here there is one condition which is very important. Just see. Alkyl halide, I just told you, alkyl halide when treated with sodium alkoxide, it must be always, what is the nature of this compound? It is always primary. The nature, it is always in the primary form, but I'll take this as secondary or tertiary. Otherwise, elimination reaction would take place. How? Just see. We have the question CH3, CH2, Cl and CH3, CH3, ONA. What is the nature of this carbon? This is primary. And what is the nature of this carbon? This is tertiary. So whenever it remove electron, here Na will remove like this and will be getting this type of ether. Now what if I am going to change the nature of sodium alkoxide as primary and this is tertiary? So what happens? The elimination reaction will take place. Now if I am going to take this as tertiary, and this as primary, then what happens? Elimination takes place. Very, very important concept. Like CH3, CH3, CH3Cl, and we have CH3ON. So what is the product form? The product form is, instead of giving ether, it will give us the elimination reaction. So is this part clear? So in Williamson synthesis, the main condition is that whenever we are taking alkyl halide, it must be the primary nature, and sodium alkoxide, it may be come in primary, secondary and tertiary, there is no problem. But if we'll consider, if we take alkyl halide as a tertiary, then elimination reaction will take place. Is that clear? So we have only 3 named reactions in this chapter: Call-based reaction, Reimann-Diamond and Williamson synthesis. Okay student, this is for today, and in the next video I am going to take up the electrophilic substitution reactions of alcohol and NaCl. Okay.